Video lecture 4, Valence Electrons and Electron Dot Diagrams. The valence shell is the outermost energy level that has electrons. Most elements follow the octet rule. They want to gain or lose electrons in order to achieve a complete valence shell or full complement of 8 electrons. So we saw octets earlier when we were talking about our periodic table, where we saw the rule of octaves that said that properties, when we placed the elements in order, properties tend to repeat every 8th element. Well, in this octet rule, we want, and elements want, 8 valence electrons in their outermost or their p orbitals. These electrons are called valence electrons and are the basis for atom-atom interactions. These valence electrons are responsible for how an element behaves chemically. Noble gases have 8 valence electrons, or they have a complete p orbital. All other elements will gain or lose electrons or share electrons in order to get those 8 outermost electrons. So let's look at some electron configurations. In this first one, how many total electrons are there? 2 and 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 1 we have 19 total electrons. What element does that make it? Potassium. How many valence electrons are there in potassium? Well, we need to look at the outermost energy level. When we look at our energy levels, 1, 2, 3, 4 is the outermost energy level. It has 1 valence electron. So potassium has 1 valence electron. Now let's look at this next one, at the second one. The total number of electrons is 7. 2 and 2 is 4, plus 3, 7 total electrons. How many of those 7 electrons are valence? When we look, the outermost energy level is 2. But notice there are 2 sublevels in energy level 2. So the total number of valence electrons is 2 plus 3. This element, nitrogen, has 5 valence electrons. Finally, if we look at nickel, 28 electrons. 2, 4, 10, 12, 18, 20, 28. So here we see 28 total electrons. How many valence? Again, we have to look at the outermost energy level. Here, 4 is the outermost energy level. This 3D, even though it comes after 4, is still in the 3rd energy level. 3 is less than 4. So energy level 4 is our outermost energy level. There are 2 electrons there. So nickel, for the most part, will have 2 valence electrons. Now, let's go ahead and look back at potassium's electron configuration. Right? Here's potassium with 19 electrons. 2, 4, 10, 12, 18, 19. 19 electrons total. So here's potassium's. We see that there's 1 valence electron. If we look at the element above it, which is sodium, has 11 electrons total. But again, notice in the outermost energy level, there's still 1 valence electron. If we look at the element below it, which is rubidium, if we look at its electron configuration, its outermost energy level is 5. So even though we have 2, 4, 10, 12, 18, this should be 4s, 2, 20, 30, 36, even though we have 37 total electrons, we still have one valence electron. So what we should notice is that as we move down a group, all of these elements still have one valence electron. If we look at the periodic table, all we saw, we'll see lithium, sodium, potassium, rubidium, and like we saw here, all elements in our first group had one valence electron. If we look at our second group, all the elements here in group 2, our alkaline earth metals, will have two valence electrons. When we jump over to group 3A, we'll see 3 valence. The carbon family will have 4 valence, 5 valence, 6 valence, and 7 valence electrons. And most of our noble gases will have 8, or a full octet. What about, okay, but why not helium? Helium only has 2 valence electrons. And why helium only has 2 valence electrons is that it only has 2 electrons. The atomic number is 2, therefore it only has 2 electrons. It's in the first period. So it only has the first energy level. The first energy level can only hold 2 electrons max. So since we have 2 electrons, the first energy level is full, which gives it a full valence shell. So let's use our information on valence electrons to write electron dot diagrams. Electron dot diagrams consist of the valence electrons and the symbol of the element. So here, if we look, we've got 2, 4, 10, we have 12 total electrons. This tells us that our element is magnesium. So if we're going to draw an electron dot diagram for magnesium, we're going to use the symbol magnesium, and we're going to use 1 dot for each valence electron. So 1 dot for each valence electron. If we're going to fill, okay, we find that magnesium has 2 valence electrons. If we look at its electron configuration, we can also look to see that magnesium is in the second group. It's an alkaline earth metal, so it has 2 valence electrons. So we're going to put 2 dots for magnesium. Now notice we put 2 dots on a single side. The one side that we put 2 dots on represents the s orbital. These other sides, the other sides of magnesium, these 3 other sides, represent the 3 p orbitals. So let's look at our next element. 2, 2, 10, 12, 18. 18 electrons, so we're dealing with argon. So to do the electron configuration, we'll use its symbol. We'll identify the outermost energy level, which is 3, and there are 8 dots. So we'll put our first 2 on this side to signify the s sublevel, and we'll follow Hund's rule and put 1 dot on each side before going back and doubling. So we have 8 valence electrons. It's represented by the 2 and the 6. If we look at zinc's electron configuration, there's 30 electrons, which means that we're dealing with zinc. The outermost energy level is 4, and there's 2 electrons there. So Zn with 2 dots. We can use electron configurations and valence electrons to help us understand the periodic table. The number of valence electrons explains why elements will have similar chemical properties. The valence electrons are responsible for the chemical behavior of the element. It's the number of valence electrons and the wanting to fulfill the octet which allow for the formation of ions. An ion is simply an element that has gained or lost an electron, resulting in the atom having a charge. Cations are positive ions. They're formed by metals. They're formed by metals when they lose electrons. The cation is always smaller than its atom because the outer shell of the electron is lost. The outer shell of the electron shell is lost. The outermost electron is lost, resulting in a smaller atom. Okay? Remember, these are positive. I like to remember it as a cation. A cation is positive. Get it? Cat, positive. Anions are negative ions. They're formed by nonmetals, and they tend to gain an electron. They tend to gain electrons. These result in negative ions. The anion is always larger than its atom because the nuclear charge is less effective at holding on to additional electrons. It causes the ion to become slightly larger. And when we look at anions literally are A, N, ion. So the N here stands for negative. So an anion is a negative ion. Let's look at chlorine. How many electrons does it have in its valence shell? 1, 2, 3, 4, 5, 6, 7. How many does it want? It wants 8 electrons. So will it be easier for chlorine to lose 7 or gain 1 electron? Chlorine will tend to gain 1 electron. This is going to result in a negative charge. If, as an atom, chlorine has 17 protons and 17 electrons. Protons are positive, electrons are negative, meaning that the charge on a neutral atom of chlorine is 0. However, when chlorine becomes the ion, the number of protons remains the same, but it has gained an electron. It now has 18 electrons. So if we have plus 17 minus 18, this results in a negative 1 charge. Let's look at fluorine. Again, we see there are 7 valence electrons. So it's still the question, gain 1 electron or lose 7. Fluorine is going to want to gain 1. As an atom, Fluorine has 9 protons and 9 electrons. Protons are positive, electrons are negative, so the atom is neutral. It has no charge. But if we gain that 1 electron and become a fluorine ion, we have still our 9 protons, and we have 10 electrons, resulting again in a -1 charge. Let's look at sodium. If we look at sodium, we see that there is 1 valence electron. So should sodium gain 7 electrons or give up that 1 electron, it'll be easier for sodium to remove 1 electron. So, as an atom, sodium has 11 protons and 11 electrons, a neutral atom. When it becomes the ion after giving away an electron, it still has 11 protons, but it now only has 10 electrons. If you have 11 subtract 10, you're left with 1. The resulting charge on a sodium ion is +1. So, let's take a look at our P&E with ions. Here we see the resulting charge. The charge is a superscript number that's put to the upper right-hand corner of our symbol. The atomic number of sodium is 11, and the number of protons sodium has is 11. The number of protons doesn't change. The number of electrons changes when we create ions. So, if sodium has a +1 charge, it must have lost 1 electron, meaning that there are only 10 electrons. Aluminum, the atomic number doesn't change, and the number of protons doesn't change. However, the charge on aluminum is a +3, meaning that aluminum had lost 3 electrons. Normally, aluminum would have 13 electrons. If it loses 3, means that aluminum would have 10 electrons. Fluorine, the atomic number doesn't change. The number of protons doesn't change. But we see a -1 for fluorine, which means that fluorine, the nonmetal, must have gained an electron. It gained 1. So normally, fluorine has 9 electrons. It's gained 1. Fluorine has 10 electrons. Oxygen has 8 protons. Its atomic number is 8. Oxygen, a nonmetal, has gained 2 electrons. How do we know that? We see the 2. Normally, oxygen has 8 electrons. It's gained 2, so oxygen has 10 electrons. Now let's look at calcium. The atomic number is 20, meaning that it still has 20 protons. And calcium is a metal, so it loses an electron. It actually loses 2 electrons, as we see, because of the +2. So, 20 electrons is the atom. It has lost 2 electrons, meaning that it now has 18 electrons.